Okay, lesson 5-8. Take out your notes packet and you are going to follow along. So some problems you'll just copy down the work that I do. Other problems you'll have to do on your own. And when it's time to do the problems on your own, you pause the video and work the problems. This is your daily grade, so you need to stay on task the entire time, and at the end of class you need to show to me that you have worked all of the problems in your notes packet correctly. Not enough just to write something, you got to work it correctly. So here are our objectives for the day. And we are going to learn about parallel lines and perpendicular lines. So these two lines in this picture right here are parallel. Parallel lines are in the same plane, so basically they're in the same flat two-dimensional space, and they don't have anything in common. Okay, they don't intersect anywhere. So even if you went forever and ever, let's draw some lines forever and ever. Okay, if you took this line and you extended it forever and ever, and you took this line and you extended that one forever and ever, those two lines never intersect. They're always exactly the same distance apart. Those are called parallel lines. So how do we know that lines are parallel? They have the same slope. So remember, if we've got two line equations, well, not two line equations, if we have a line equation, y equals mx plus b, the slope is the m. So the number that's filled in for m on both lines that are parallel will be the same. And then if you're dealing with vertical lines, all vertical lines are parallel. So we need to find out in this slide which lines are parallel, and it's hard to tell, but there's 4 different line equations here, so let's split them up. Okay. So what we need to do is we need to figure out what's the slope. Okay, this one is in the y equals mx plus b form. Okay, so slope is the number that's in front of x. So our slope here is 3/4. That's our slope. This one we are going to need to solve for y before we'll know what the slope is. Alright, well, I shouldn't have written that right there because I need to work in that space. But we're solving for y. Okay, there's y right there. It's on the left side of the equal sign, so this negative 3x has to move to the other side of the equal sign. It's negative now, so we'll move it by adding it on both sides. Those cancel out, so 4y equals 32 plus 3x. We cannot add those, so we will just leave them separate. So we'll say 3x plus 32. Then we still want to get that 4 and the y apart. They're multiplied now, so we'll get them apart with division. Everything gets divided by 4. Okay, those 4's cancel out. Y equals 3/4. Leave that in a fraction. Fractions are always better when you're doing lines. 3/4 x plus and 32 divided by 4 is 8. Okay, slope is the number that's in front of the x. Alright, so our slope here is 3/4. This one, slope is the number in front of x. Okay, so our slope here is 3. And this one, this is written in the y minus y1 equals m times x minus x1 form. That's called the point slope form. Okay, so the m is the number that's in front of the parentheses. This one, so here m equals 3. So parallel lines have the same slope. Okay, so these two are 3/4 and 3/4, so those ones are parallel to each other. And these two have a slope of 3. So those two are parallel to each other. Take a moment to pause the video and copy this down if you need to. Now we're going to show that these 4 points here, 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 and here are the vertices of a parallelogram. Well, a parallelogram should have parallel slides. So from A to B should be parallel, from D to C should be parallel, A to D parallel, and B to C parallel. Okay, let's look at from A to B. From here to here. Let's find out what the slope from here to here is. All right, remember our slope formula is m equals y2 minus y1 over x2 minus x1. Okay, y2, right? We're just going to go fast here. So there's the y2, x2, x1, y1. So for these two, y2 is 2 minus y1, 2 over 4 minus 0. Okay, so this 2 minus 2 is 0, 4 minus 0 is 4. So this line has a slope of 0. Let's look at from here to here. Okay, that can be x1, y1, x2, y2. Let's see if those are parallel. So we'll go -3 minus -3. I'm just filling in my slope formula again. Over x2, 1 minus x1, -3. -3 minus -3. Well, minusing a negative, that's the same as adding. Okay, so -3 plus 3 is 0, and 1 plus 3 is 4. So again, we have a slope of 0 over 4, or just 0. So our slope here is 0. So these two lines have the same slope, so those are parallel. That's good. Make sure you have all this copied down because I'm about to erase. Okay, let's look at these two lines should be parallel. So let's look from here. Oh, I wanted to do that in a different color. Hang on. Well, no, never mind. Okay, let's look from here to here. So this will be x1, y1, x2, y2. So we'll fill in this formula. So y2, -3 minus y1, 2. Over x2, -3 minus x1, 0. -3 minus 2 is -5. Over -3 minus 0 is -3. And -5 divided by -3. Negative divided by negative is a positive. So it's 5/3. So the slope of this line is 5/3. Okay? And then let's do the slope of this line and see if it's parallel. So this can be x1, y1, x2, y2. Okay, fill in our little formula. So y2, -3 minus y1, 2 over x2, 1 minus x1, 4. -3 minus 2 is -5. 1 minus 4, that's -3. -5 divided by -3. Negative divided by a negative is a positive, so that's 5/3. So this slope is 5/3. Good. So these two, hang on. These two lines are parallel because they have the same slope. And these two lines are parallel because they have the same slope, and in a parallelogram, the sides that are opposite from each other should be parallel. Good, we do have a parallelogram. We've proven that. Now let's look at perpendicular lines. Perpendicular lines make a right angle. They make a right angle to each other. Those are perpendicular lines. You know you've got a right angle when you've got that little square drawn in the corner. Okay? So if you've got non-vertical lines, they're perpendicular if you could multiply together their slopes and get -1. Don't worry about that. We're going to talk about that in a second. And vertical lines are perpendicular to horizontal lines. There's a horizontal, there's a vertical. Those two are perpendicular to each other. So the way you know perpendicular slope is you take the opposite reciprocal. So here is our first slope of our first line. If we had a perpendicular line, then it would be negative. This one was a positive. You'll do the opposite. So the opposite of positive is negative. And then you take the reciprocal. You flip 3 and 2 upside down. So now it's 3 over 2 instead of 2 over 3. Okay, 1 over 5, we take the opposite of that. So it's positive now. We take the opposite, negative, and we flip 1 and 5 upside down. Okay, so this becomes like 5 over 1. But that 1's invisible because you don't need it, because 5 divided by 1 is just 5. -7, okay, that's like -7 over 1. So we take the opposite of that. It's negative now. We make it positive, and we flip it upside down. So it becomes 1 over 7. So original, perpendicular, perpendicular, the original, and the perpendicular. Or it can go the other way around. But these are perpendicular to each other because they're negative reciprocals. So let's see if we can figure out which are perpendicular. Okay, again, we're just finding the slopes. Does this one have a slope? No, that's like plus 0 times x, because 0 times x is 0. So our slope here, or the m, is 0. Okay, that's a horizontal line, incidentally, because horizontal lines have a 0 slope. All right, this one is in the y minus y1 equals m times x minus x1 format. It's in the point slope formula. So m is the slope, m is 5. So here our slope is 5. X equals 3. Okay? There's really no slope here because slope is whatever's in front of x. Okay, but it would have to be in the y equals mx plus b format. It's not. If you graphed x equals 3, you would just find 3 on the x-axis, and you would draw a line that goes through 3. That's a vertical line, right? Vertical line. Okay? And then let's look at this one. This is the y equals mx plus b. The slope is whatever is in front of x, so this slope is -1/5. Well, we learned just a minute ago that horizontal and vertical lines are perpendicular to each other. So this line and this line are perpendicular to each other. And then if you don't have horizontal and perpendicular lines, then the negative reciprocals are perpendicular. So this one is positive 5 over 1. If we wanted the opposite of that, we would go negative, and we would flip it upside down, 1 over 5. So negative 1 over 5. So these two, this one and this one, are perpendicular to each other. Show that ABC is a right triangle. So we want to prove that this is a right triangle. A right triangle has a 90-degree angle somewhere. So there should be 2 lines in here that are perpendicular to each other. Let's, on a hunch, find out what's the slope of this line, and then we'll figure out what's the slope of this line. Okay, so let's find out the slope from A to B. There's x1, y1, x2, y2. Okay, so we're going to fill in our slope formula. Okay, so y2 is 2 minus y1 is 0 over x2, 1 minus x1, so minus -2. Okay, so 2 minus 0 is 2, and 1 minus -2 Minusing a negative is positive, so 1 plus 2 is 3. Okay, so the slope of this line here, that one there, is 2/3. That's its slope. Okay, let's figure out what's the slope of this line right here. Okay, let's do it in a different color. This slope. Okay, so again, this can be x1 and y1 because we're going to go from point A to point C, so this will be x2 and that'll be y2. Okay, y2, -3 minus y1, 0, over x2, that's 0, minus x1, that's minus -2. -3 minus 0 is -3. And 0 minus -2 is the same as 0 plus 2. Okay, so that's -3 over 2. Look, so this one's positive 2 over 3. So the opposite of positive is negative. That's 2 over 3. This is 3 over 2. So this is the negative reciprocal, or the opposite reciprocal of that one. So these two are perpendicular. Those are perpendicular lines, which means we get a right angle right here. And a right triangle is one that has a right angle in it, so we do have a right triangle. Make sure you get all that copied down in your notes. Okay, let's figure out, are these lines parallel, perpendicular, or neither? All they've given us are the slopes, and that's all we need to know. I think you know enough now that you can just write in the answers. Parallel, perpendicular, or neither. That's what you're going to put on these lines here, here, and here. Okay, now these are pretty much your turn. Write an equation in slope-intercept form for a line that passes through this point and is parallel to this line. Okay? And so you've kind of got some steps here. Parallel means it's going to have the same slope. So you don't need a new slope. You can just keep that slope right here. And then well, that was kind of like step 1, was to find out what the slope was, and that's the slope. And you want the same slope because it's parallel. And then step 2 is going to be write it in point slope form, having it go through this point. Oh, well, I'll do this one for you. Okay, so point slope form is the y minus y1 equals m times x minus x1. This is the formula for our new line, the parallel line. So y minus, and we want to go through this y point, 7, equals m. We're going parallel, so we want the same slope, so 4/5 times x minus, and x1 will be this x coordinate right here. And then step 3, in order to get it into slope-intercept form, because that's what they want, step 3 is to solve for y. So we'll distribute this 4/5 through here. Okay? And so I'm going to have to erase some things in order to make space, so make sure you have everything copied down. So I'm simplifying out this. So I'm just going to copy my y minus 7 up here, equals, and I'm going to distribute this 4/5 through. So 4/5 times x can just be 4/5 x. And 4/5 times -5, well, these 5's cancel out. So it's just 4 times -1, and so that's -4. If you don't believe me, put it in your calculator. All right. And now we want to isolate the y. We want to get y by itself. So that -7 has to move over. So we'll add 7 here, and we'll add 7 there. Those cancel, so y equals 4/5 x plus 3. So we wanted it in slope-intercept form. That's the y equals mx plus b. And here we go. There's our final answer. Y equals mx plus B. Good, so we're done with that one. All right, now you already know how to do this, so you try example 7. Pause it and try it. Example 8. Same thing, but this time they want perpendicular, so you're going to do the same exact steps that we did before, except for now you want a perpendicular slope. So now your perpendicular slope has to be perpendicular to this slope right here. Remember, slope is the number in front of x. So our original slope was 5. Okay, that's the same as 5 over 1. Perpendicular is the opposite. It's positive now. We take the opposite and we flip it upside down. So instead of 5 over 1, we're going to have 1 over 5. So there's our slope, and then you follow the same steps that you did for the last 2 problems. And this is our last one. Okay, so we want perpendicular to this slope, so you get the opposite reciprocal of -2. And remember, that's like -2 over 1. So opposite reciprocal of that, and then you follow the steps from the problems we did before. Okay, it looks like you're done. So again, fill in your notes, rewatch parts of the video if you have to, and show me that you have done all the problems in your notes correctly to get today's daily grade. Thanks for watching.